All right, so I made some more data that actually has not a numbers in it. So if I load this, actually, I'll just go ahead and do it this way. I'll load the data and plot it. You can see that I just literally randomly took out chunks of data. So like if you were looking through a telescope and the moon got in the way, then you're missing data. So there's a couple of things that you can do, but mostly I just wanted you to know that MATLAB does have some tools to handle this. It has, oh gosh, what is it called? I have to remember. Help NaN. Is NaN is missing, fill missing? I think that's what I want. There's a thing called fill missing. So like if I open this up, see, it says not a number, etc. Okay, so there's a thing called fill missing, and I think I opened up the thing for it already. Okay, so there's all this theory on how you might want to fill it in. I'm just going to use a linear method, which basically just means it takes an average and puts it in the closest spot. You can go, I want the nearest non-missing value, I want the next non-missing value, the previous non-missing value. This one is basically give me an average of those two values. This one do some interpolation. There are some other things that are derps beyond the scope of what I want to worry about in this course. But for these purposes, I'm just going to do a linear interpolation, which basically means it's just going to average the two things around it and stick it right there in the middle for whatever it thinks it's missing. So let's go back over to MATLAB. And so MATLAB, come here MATLAB, there you goes, there it goes. Okay, so what I can do is, let's try, so I think t is all there because I know all the values of t. Yeah, t is all there. So I just need to fill in the values of x and y. So I can go new x equals fill missing for the x with the method, I'm going to go with linear. And then I'm going to do new y fill missing y. I can't spell missing consistently, apparently. I can't spell fill. And I'm going to go linear again. And then just for funsies, I'm going to plot x and y like that. And then I'm going to plot in blue. And then I'm going to plot new x and new y as red, and maybe it'll pop out, except I think I'm doing the opposite of what I want. I think I want to redo the order of those. Yeah, I want to flip the order. I'm going to do this one second so it's on top. Okay. Okay, so then you can see, I'll even make them a little bit bigger so that you can see what's going on. I'll do it this way. No, I'll just do it this way. This is good enough for government work. Okay, so if I come over here, I can see here, this little chunk where that's been filled in, and I can go look at this little chunk right here where it's been filled in. Now if I wanted to get really clever, why did I hit negative? I meant positive. I'm trying to think if there's like a clever way I could look at this. It's really bothering me that it's not prettier than it is. Maybe I could do something like plot and then hold on, and then maybe I'll make these all like stars so you can see them better, but I'll make this one line width 2 so it's thicker. No, that's not really what I wanted it to do either, but I think just making them line width 2 is being thicker is better anyway. I just think that's easier to see. Yeah, so you can see the chunks right here where they're a little bit fatter than they need to be. So you can see how it just draws a line, and I think that's easier to see now. Let's see. Yeah, see how that's a straight line? So it's not a polynomial, or a, you know, a parabola, which might make our poly fit not as good as it was before. I wonder if I can just pull that from earlier. I can just remember. I'm just going to poly fit the T and the Y to see if I can get 9.8. Well, yeah, so it can't do it on the Y because the Y is missing stuff. So I have to do it on new Y and see if I get the right thing. Maybe I can't. Why are you being like that? Not enough input arguments. Poly fit. Oh, I also need to tell it it's a squared. Okay, so that's negative 4.9, which is actually really close, times negative 2 to 9.81. So good, even with by putting in the stuff, it still comes out pretty good. What are my other options? I'm trying to remember. I could fill it missing with previous or nearest. I don't know how much of a difference it's going to make. Previous. Okay, so you can see how it changes the estimate for gravity there. Nearest. Okay, so that's not a huge difference. Makima. Makima? I don't know what that is, but I'll bite. Let's use a Makima fit. It looks like it was pretty much the same as linear. I probably wouldn't notice unless I did it for realsies. If I do a Makima fit, can I see a difference in the picture? Ew, that's not what I expected at all. Let me try this again. There we go. Okay. Oh, it's because I had the hold on and I kept replotting it. So that's a Makima fit, y'all. And I guess I can show you what the nearest option looks like. See how it goes over there? And it's just like, I'm just going to pretend it's the same thing, you know, so you got these little steppy functions. So anyway, just something you can do, because sometimes you do end up pulling data that is incomplete, and Matlab does have some tools that you can go around and play with it. So whether you have NaN or other stuff like that. In fact, I think I probably could have used this whenever I was playing with data from telescopes, and I did not know that this was a thing, and I like it. This is pretty fun.